Swayam Prabha. Digital India. Educated India.
Hello everybody, we are back to lecture 3 of the module, which is glass and ceramics, and again we will try to learn more of glass in this particular lecture. In the previous lectures, actually in this module, we tried to understand the different types of glass, and we also had seen how we can actually reduce the fragility or the safety and increase the safety by laminated glass, by reducing the solar heat gain within the system, by putting various kind of measures. We also understood strengthening of glass, that is tempering glass through heat treatment, and now in this particular lecture we will expose you to the fixing of glass. As you can understand, it is a very fragile material and it is a very thin layer. We have to be very careful when we are fixing it. Particularly, our application is more in the domestic area, and special areas are there for which special glasses are also used. So, we in our country context mostly go for single glazing, that is, it is only one layer of glass, one piece of glass protecting from the environment, giving you visibility, and at the same time you have to remember it should be safe enough. So, it should not fall off from the system where it is being placed. So, usually as you see, our domestic windows and doors where we use partially or fully glass, we have the wooden frames, the iron frames and the aluminium frames. And from the point of protection from weathering conditions, we have to understand that there should not be any gap or very minimal gap between the outside with the inside. So, you need to place the glass in such a way that it should not allow any air or dust, dirt, wind, etc. to enter in. This at the same time helps in preventing the internal thermal condition to get exposed to the or to get exchanged with the outside condition. It may be flowing from outside to inside, or it may be from inside to outside, whatever is the condition. So, it must be capable of giving that thermal protection. Again, if you walk around in cities, if you see a institutional building with a large entry, nowadays in most of the places you will witness glass facade completely without any framing. That is another kind of assembling where the glass can actually stand and give you the protection or promise you the protection which a framed glass wall, framed glass panel can promise you, or maybe a wall can promise you. You can see in the front of shopping malls, you can see in the front of a hotel. So, we have to also see how that kind of framing is done. Needless to say, this kind of glass will be the strengthened glass or the toughened glass or the tempered glass. Along with this, we will also try to know double glazing because it has some thermal advantages. Next is the cleaning of glass. Yes, this is a long lecture. Cleaning of glass. As you all see or as we all appreciate glass, just because it is clean, just because it connects you to the outside, but if it is full of dust and dirt, you will feel like going and cleaning it. But say at a very high height, if you cannot have access, you cannot clean it. From indoors it is possible. from outside it may not be possible, and that will lead, or that will be the closing part, where we will see hydrophilic and hydrophobic glass, which are actually nano coated glass which can self clean itself. So, this is not much into use, yes, but it is a coating which helps the glass to clean itself, yes, under certain conditions. So, let us move gradually to the next slide. So, this slide you see that the glass is fixed on a wooden frame. So, the objective is, glass is very fragile, we are using very normal plate glass, sheet glass, or maybe float glass. So, we are not entering into any kind of drilling, attaching, making any welding. So, we are having a frame system where we are actually putting in the glass piece. You can see the two wooden frames, and you can also see the putty here. This can be a putty or maybe a glazing bead. So, you can see there is a small gap to allow any kind of expansion of wood as well as glass. So, this sealing is to be ensured to ensure weatherproofing, as you can see the points, and to make it energy efficient, that is no heat movement will happen. So, internal thermal condition will remain intact. Now, you can see here it is written putty or bead. So, bead may be again a wood piece attached to, fixed to the main frame by means of nails. Now, how is this initial position of this glass kept? The initial position of this glass is kept by nails. You can see here, set in position by nails and then finished with putty or acrylic latex or silicone caulking. So, either it should be a bead fixed with nail or fixed with nail and then putty on all sides of it, all edges of the glass piece. And what is putty? It is nothing but calcite lime mixed with linseed oil. This linseed oil gradually, very slowly evaporates, and the putty remains in position in a stick. It is a sticky kind of item and it can stay together for few years. But remember, you have already fixed the glass with nail. So, even if a portion of putty comes out, the glass remains in position. So, putty can be taken out, resealed, and there is very less chance of the glass being broken unless otherwise it is facing any kind of impact load. So, visibility is given and the glass is in position. If we move to the next slide, we see the fixing of glass on iron frame. Now, here you can see some sections, details which you might not have been exposed to till now. So, this is a kind of section which is called Z section, which is holding the frame, which is actually forming the frame. And you can see here the sealants, which are, here is a T section, here is a Z section, and you can see the sealants into which the glass is being embedded. So, yes, after holding the glass, it is the same putty which is holding the glass in position. But you remember, here there are no nails being fixed because you cannot fix nails within the iron section. So, it is only the putty which is holding the glass in position. Hence, time to time maintenance to ensure safety of the particular building, and particularly when it is at a higher level, one has to be very cautious of it. Let us see what happens in aluminium frames. As you all know, because of environmental reasons, we are not more into the wood frames. We have moved to iron section and yes, aluminium sections, aluminium frames. In this also you see that the glass which is in blue is set within the frame and there is a sealant applied here which is keeping the glass in position as well as helping in the weatherproofing part. So, there may be gaskets, there may be press fit clips, aluminium is soft, press fit clips that goes inside the spaces and holds the glass in position. So, maybe wood is there, but you can always recommend aluminium frames which has a better locking system of this glass within the frame. So, sealants here are also applicable, but gaskets are usually used and also the press fit clips of aluminium which keeps the glass in position. This is maybe the best amongst the three. So, now let us come to the structural glazing or called the frameless glazing system. You can see the pictures here which are called spider joints. Maybe few of you have seen these also. So, glass is fixed here without a frame. It is point fixed using spider web joint. You can see various directional views. The first one you see here, you are seeing from the front. This is from the, after being installed, you can see from the back side you are seeing like this, from the side you are seeing like this. On this image you can see this is a door being fit within this kind of frameless joint. So, here there are wooden supports in which the pivot kind of fixing hinge is being pushed into and the glass panel, the glass door panel can actually move. Glass is usually tempered glass as it has to withstand all kind of impact forces. So, no one is going to support it, there is no frame to support it. So, glass has to be strong enough to withstand any kind of impacts. The size of the supporting structure, as you can see here, there is a glass member on which the entire thing is resting. So, this is again an inside glass support on which this frame is resting, this joint is resting. So, it should be sufficient enough to take the entire load of the glass facade. Sometimes it ends up into a steel rod also. These images are taken from our gymkhana apart from this one picture. So, these here it is a two floor atrium where there is a glass facade. So, this glass support is actually holding glass in position. It may be a steel rod which is holding in position, that you will see mainly in shopping malls which are even much higher in height. That means the facade is maybe 2 to 3 floors and you can see such kind of steel rod supports. Holes are made in the glass before tempering. This has been told earlier also. If you can recall, tempered glass, on tempered glass you cannot do any kind of working, like even cutting, drilling, welding, nothing can be done. So, these locations where these spider joints will come are all to be designed, pre-designed, ordered, and when it is made in the industry, it comes exactly what it has been ordered, and here you are only fixing it up. Panes must be sealed using silicone mastic applied to an extruded silicone seal. you can see in between these gaps of the 4 glass panes, you see a item which is sealing, that is silicon mastic, not the putty. It is put in, it has a longer life and it is more or less colorless. So, the joints which are formed are very thin and very much matching with the background, that is, it is almost merging with the glass. So, that gives you a seamless look that it is entirely glass. But yes, there are joints, there is silicon inside it, silicon mastic inside it, which is sealing it from the weathering condition as well as from thermal exchanges. Glass further may have laminations. As I have told you, long buildings, tall buildings entirely of glass, they need to understand what is the solar gain inside the building. So, you may require to reflect a part of the solar radiation, and that is why you may add laminations on top of it to control the heat entry. And here is the use: external facades, curtain walls of buildings, show windows, shopping malls. These can be the various areas where you can apply such kind of glass walls, which will give you as if it is a brick wall, but will give you the transparency. Now, let us come to the next slide. Till now, whatever we had discussed was around single glazing. As you see, the U value is 5.9. You can see when two panes are there with a glass with an air gap in between, which is almost 12 millimeters, and the glass plates are 4 millimeter each, it reduces the U value even more than half. And you see in the third picture, the U value has further gone down with this dotted line here. What is this dotted line? This is an low E lamina. So, if you can add a lamina inside while you are making, it will further reduce the U value. Let us see what happens here. It is the solar radiation which wants to enter in the red line, but eventually a part of it is getting absorbed in the glass pane, part of it is reflected out. Whatever is entering is again having a convection inside the air between, sandwiched in between the two glass panes. Some conduction is happening between the two glass laminas, glass sheets, and some part is being radiated inside. So, after all these stages, a percentage is entering and not at all the whole. If there was only one glass, the entire phenomena would have happened like the red line, and a part is being absorbed by the glass, a part being reflected, and the rest is going in. Some is going to through the conduction process, but having two layers with an air in between is leading to further cutting down of the radiation inside the building. So, you are actually getting a lot of heat loss through this assembling. So, this low E coating is giving that added advantage. If you see further, if this air which is inside is extracted out by some mechanism and argon is filled in, it may be vacuum or it may be argon inside, then it will be further reduced. So, you see the values with a double glazing with argon infill is 2.6, where it was here with air infill was 2.7. Now, again here you see with the E coating here, you see it has gone down by 1.6. But if you see putting 3 glass, let us think that we are putting 3 glass with air in between, you will achieve what the argon with 2 layers is having, or maybe almost equal to this alternative, where you do not need to fill argon, but you are putting the E coating and the two layers of insulation, sorry, 2 layers of glass. What is happening in the triple? You are increasing the weight, you are increasing the material cost. Here by putting a lamina, you are reducing the U value. These are required where there is large glass facades. As I had shown you a picture of high rise, you can have lots of glass surfaces, but you do not want the heat to be entering. So, you can actually use this insulated glazing units. Let us see what is happening when we are having these double glazed units. The insulated glazing unit IGU, and when we are looking only for the 2 layers, it is double glazing unit. You see 2 parallel panes of glass with an intermediate buffer zone assembled where air is there or argon infill is there. What is more to be noted is the sealing of this entire assembly. So, let us look into a larger section of this particular area. What you see, this is one glass, this is the other glass, but here you see in the frame there is a primary sealing, there is a secondary sealing, and there are desiccators. So, why is this sealing important? Because any kind of leakage will lead to a malfunctioning of whatever calculations are being done when you have installed this. So, sealing the entire system is of primary importance. So, this is the kind of section which will be developed eventually, that will come from the market, which will ensure the sealing, and this should be having long term adhesion to the system. So, this structural integrity will be maintained if there is a long term adhesion. So, it should be unaffected by the ultraviolet rays of the sun, and it should be durable even in moist condition, because a part of it will always face the weather, the natural conditions. A part of it will always remain in the artificial or the controlled condition. So, any kind of changes, it should be capable of withstanding. So, sealing needs to be ensured to avoid any kind of leakage, and then only the performance of a double glazing unit can be appreciated to the fullest. Now, let us see another application of glass. We are not entering into the solar panel detail, but on top of every solar assembly, solar photovoltaic cell, there is a glass protecting the entire system. The entire system has been redrawn from some image where you see, here you can see the glass, aluminum frame and the ceiling, which is of very important, and the glass here, and below is the solar photovoltaic assembly. What kind of glass it should be? It should be highly transmissive glass. It should not reflect the solar radiation. It should attract or entrap the solar radiation, and it should have high strength, because we are trying to get the maximum sun. So, it may be in any inclined position and it can face any kind of impact. Changing it is again a difficulty. So, transparent conductive coating or anti-reflecting coating may also be added to it to increase its efficiency. So, this is another area where we see the application of glass, and also these should be cleaned with water, vapor and cleaned and should be washed with water, vapor and should be free from any dust and dirt to get the maximum energy from the sun, to trap the maximum energy from the sun. Now coming to cleaning of glass surfaces. As I have already told you, we can only appreciate the glass surface when we can see through it. We cannot tolerate maybe a dirty, unclean glass surface. So, visibility and efficiency changes with dust and dirt. Periodic cleaning becomes problem on heights, and cleaning with water system is the easiest. Usually from below you can water up to say 2 floors, 3 floors up to a certain height, but it may not be the same when you are going higher and higher. You can have hook and loop system where you can see the person is hooked up, he is moving up and gradually or eventually cleaning the surface. You can see a portion of it is cleaned, a portion of it is being cleaned, and this is very much human intensive. If you see another kind, you see here it is platform which is suspended in the air. It is also called gondolas, which is usually an elevated rig that moves on rails on the entire building. Here it is the crane which is actually lifting the person and he is doing the cleaning job. This is a time consuming and effective way of cleaning, but it has to be done time to time. Another is crane being hoisted on the top of the building and it moves up and down and length and from the length to the width side, top to the bottom side, and it is doing the cleaning operation. So, having just large glass facades also calls for such kind of maintenance facilities which are to be done, otherwise you won't get a good clean glass surface. Now let us come to the self-cleaning glass. These are applications of nanotechnologies. These are mostly seen in automobile industries, but gradually entering into the domain of buildings. It is a polymer coating or a titanium dioxide coating which actually attracts water. There are two phenomena happening, you see. Photocatalysis, when in contact with sunlight the titanium dioxide gets electrically charged. Electric charges destroy the dirt or the grease which is adhering to the surface and changes them to water soluble substances, and the attraction of water is it is attracting water, and these soluble substances are getting washed away by means of water. So, this is a method where actually you are looking for water to come and clean, but prior to that due to the presence of sunlight, these dirts are getting loosened, getting converted to water soluble substances which the water can eventually flush out. So, self cleaning glass requires proper sunlight to break down that dust and grease because of the presence of the titanium dioxide or of the cross linked polymer coating, and at the same time you need efficiency, you need water to make it efficient. So, if it is getting rainfall, it will be more cleaner than what the normal rainwater would have done. So, this grease kind of things, the oily substances that won't be washed away by water would now get washed away because of this kind of coating. We have another kind of system which is hydrophobic glass. What you see in a lotus leaf, it is always on water, but the water is not actually spreading, it is getting or forming a circle, it is a droplet form. So, it is always trying to get off from that surface. surface may have striations, surface may have it should be in the other direction, surface may have lots of striations, and wherever dust and dirt etc. are there, this kind of substance, this kind of water droplet will actually carry these along with it and will run down gradually. So, one is the recessed contour which do not attract dirt. So, these portions the dirt will not get into, it will remain on the top, and this by coating with silica gel or oxides of polyurethane or by having recessed contour, it makes it oil resistant anti-smudge surface which stays cleaner for longer duration of time. So, these water droplets which is coming is having low contact with the surface or the hydrophobic surface, which may be polyurethane, oxide of polyurethane, or maybe of silica gel. Below this is glass and it is leaving the surface clean. We can see a better picture which has been adapted from a picture in the internet. So, here you see in a hydrophilic surface, it may not clean the dust and dirt which are the brown small portions shown, whereas in a hydrophobic surface this water droplet is actually taking or carrying the item and moving down. In this process you need heavy rainfall to actually take this thing off after the grease and the oil is digested. Digested means it has been changed or transformed into other form due to the action of the sun rays. Here actually the dust and dirt are rolling down with the droplet. So, these are the two phenomena which are happening, which I am exposing you to, and this is just the beginning of some nanotechnological applications which are not at the moment largely applied in our building industry. So, we can conclude that glass can be fixed in various ways. The process of fixing glass is called glazing, though glazing has another meaning, but in this context glazing is the fixing of glass. Glass can be effectively used as a thermal barrier when used as a composite, that is when it is glass, air and glass, it forms a composite. Cleaning of glass is an important aspect to maintain visibility and is an important task at heights. Various modern or advanced technologies are being adopted for high rises etc., where you can do this work in a much easier way. However, they require their preconditions. So, we conclude this section, this particular lecture, and we will move on to the next lecture, that is lecture 4, where we will try to see glass in another form. So, thank you for now.